So, first, let me introduce myself. I'm Tomáš Soukal, and I'm security consultant. I'm from Talsec. We are a mobile security company doing a lot of mobile security research, focusing on protection SDKs for application clients and for backends. So this is more like case study of what can happen if someone steals your JWTs from your apps. So this is like a really serious issue for app owners, because once your application can be impersonated, you have a serious issue which you can't solve on backend side, neither on front-end side. So in Talsec, we are solving such issues every day, and we wanted to share our knowledge, what are possible issues, what can happen, and what we can do to prevent it. Okay, so as I said, we are mostly focused on in-app protection, so we know a lot about hacking, about protection against reverse engineering, how to detect hooking frameworks, how to check some integrity aspects of your application. So we already know how to protect your application, and now the most current situation is that applications can be really protected by various rasps, various shields. So Talsec decided to go one step further and to explore the options for backend protection, of how to detect or how to improve this impersonation issue. And that is that oftentimes there is someone who might try to harvest JWTs from your users and then impersonate those users on your backends. So this is a serious threat, and this is something we put together to more teach you what are your options if you want to fight such kind of attacks. Okay, first acronym for start, TOFU, not only the food. It's trust on first install. So if you drop your application on someone's phone, can you really trust this device? Can you trust the OS? Can you trust that this application client, which seems like your application wasn't repackaged or wasn't tempered in another way? So can you really trust this endpoint? Of course, the answer is not. So we are trying to overcome this and to provide at least some security, at least some insight into this enrollment, into this first install, and tooling and usual areas where you would look if you want to prevent, when you want to know that you are dropping your application and maybe further some sensitive assets, keys, whatever, on a client. So the areas you want to check are app shielding, app attestation, TLS pinning, or secure storage. These are the areas where the security lies nowadays. Okay, I'll move on to the first part of this talk, and that is how to steal a JWT. And don't expect anything magical. I will be showing just simple things any hacker, any of you in this room can do at home to extract JWTs and to prepare some kinds of simpler attacks. So the simple structure will be extracting of JWT tokens, then how to make a malicious clone of application suitable for harvesting, and how to use this token for spoofed network calls. So this basic scenario will be the first part of this talk. For this, I prepared a simple application which is based in Flutter, but it doesn't matter, the technology is secondary in this talk, and I will show you the token which is used in this application. This application uses Firebase auth, and it again really doesn't matter what authentication provider do you use, or if you decided to roll your own authentication scheme based on the JWT tokens. So I will use this application, which was like to simulate some transactions, because a lot of applications today offer some kind of fund transfers, so it's more sensitive and better like to understand what's the threat here. Okay, here is the traditional Firebase backend I set up with authentication. So this is custom backend dropped using Firebase functions. Again, simple REST endpoint. I've got 2 endpoints. You will see the difference later. And this endpoint does basically nothing, only answers to requests. Okay, this application, I'll drop it on my emulator and test drive it. So I set up my credentials, and the moment I set up the credentials and I hit sign in, the Google server will grant me a JWT token. So this JWT token, this thing, I'm not sure if you've seen how it looks, so we will see it in a minute. This JWT token is now dropped somewhere in my application. This is a standard feature of Firebase auth library or AWS or any other JWT provider. So here is the sensitive part of the application. So let's assume we have some functionality which allows users to share credits or transfer funds between each other. For example, it may be some phone operator application, it may be some meal ordering application, you know. Okay, so I can select a recipient, some amount I will be granting to the recipient, and when I hit the button, the funds are transferred. In my case, I have just simple answer like code 200. Okay, I'll skip some boring part of the compilation, and now I dropped to back to my emulator. If I have a rooted emulator, as you had a really great talk about security, my colleague before lunch. So if I have a rooted emulator, I can access simply the storage of application. So I can look inside any application on such emulator. It's natural, but sometimes developers forget about this and are stuck in the sandboxing concept and forgot that this is not always true and not always granted. So in this case, when I open shared preferences, here is a magical file called com.google.firebase.auth.api.store and then some random garbage. This file is the JWT. It's in every application which uses Firebase auth or any other Firebase or similar auth provider. So you can simply find this file and open it. Okay, I will do it. And it's not very visible, so I will maybe zoom a little bit. Okay, here is the file, and the highlighted part is the access token itself. So this long string is in fact base64 encoded JSON. So I will show you. I put this JWT into this JWT.io debugger, and I'll again, not this time. I will, you can see the pink part is the like identifiers or identificators of my person. So you can see there is my user ID, my email, and other things which definitely show that this is mine. So this is JWT token. So if you've never seen JWT token before, here it is. This is JWT token, nothing magical. Okay, I'll go back one step. So sometimes people like to argue that Android ecosystem has become much more mature. There are no rooted systems and threads like that people tend to trust much more the sandboxing. And that's great, because it's right that Android has really improved in terms of security, and the overall ecosystem is much more sound nowadays. But yet, still, there are various threats possible. So I have a few examples here. I'll go from left to right. On the left side, of course, you can root your device yourself. That's what reverse engineers and testers like to do, so they can create their own rooted device. That's a possibility. But more serious threat is that there, from some time to time, emerge even pre-infected devices. And that means that even some vendors may maybe unknowingly roll out device which will come with some backdoor access or with some issue which will allow attackers or someone in a process to access devices internals, to drop some applications with higher privilege access. So even pre-infected devices are a threat still and still persist. Another kind of environment which may be used by some hackers or people who would want to do some nasty things are rooted emulators. Usually there are gaming emulators used for playing games on, for example, Windows computers, where you can drop application and play your game comfortably from your phone, from your device, PC. But these emulators often come with rooting access, so you can, on one click, enable rooted access to this device. Another kind of vulnerability which breaches this sandboxing concept are third-party dependencies. So this is a traditional issue that ideally, in a good world, you should check every code you drop into your application, every dependency, every vendor who gives you some SDK should show you what's being done. And the issue is that if such third-party dependency tries to access your internal files in your application, it definitely can, and why not, of course. So any third-party dependency in your application, anything you included into your Gradle, anything can access, for example, the set JWT. So this is a serious threat. And maybe this dependency is completely safe initially, but it may be weaponized later in its life cycle. So one time in the future, your future self will just hit update the dependencies, but the dependencies may have changed in its lifetime. So another kind of breach may be happen on when there are some new OS exploits or unpatched OSs. This thankfully isn't as common nowadays, but there still emerge threats like, for example, hardware chipsets issues. For example, there was some dirty cow attack possible like 2 years ago. There was some rooted emu named attack 1 year ago. So even hardware attacks happen from time to time. This is most important to know that we are usually thinking about the devices by well-known brands which we use now every day, but I bet a lot of you are also developing applications for some industrial devices by less proved vendors. There may be some like cheaper third-party devices for industry, and in those cases you don't have as good level of security as you would usually have with well-known brands. So in those cases there is still a lot of uncertainty coming into your business. And the sixth one is a repackaged clone, and that's the simpler attack case or use case which I will be presenting now. So if someone takes your application, repackages it, stuffs it with something bad, and then distributes it amongst your user base, you have a problem. Okay, I'll take this application from my emulator, so I ADB pull this APK from my device to my computer. And on this computer, I will do the reverse engineering work. So you can see there is a base APK. That's the file I'll get when I'll ADB pull the file from emulator. And I'll use APK tool to decompile the application. In this case, there are a lot of Flutter developers between you. I wanted to emphasize that APK tool and other hacking concepts work the same for Flutter applications as they do for Android applications, okay? So in this case, the application was initially written in Flutter, but the concepts are the same. Okay, here's my decompiled application, and when I'll navigate to its directory, to its smiley file, I'll see the code itself. So let's check it out. Here is a main activity. So again, I'll emphasize that this was written in Flutter, but a lot of part of code is still the same for Flutter applications as it is for Android. So here is the main activity, and here is another file which may be interesting. And what I'll do is that I'll write a payload which will allow an attacker to get out the token. So let's write another project. I just set up a new project in Android Studio and return a simple main activity with a steal function. I will scroll a little bit down. So here is a simple steal function that will act as a payload. This is something everyone can do. So this will basically check the shared preferences directory, check if there is any file which may contain token, and if there is this token, this part of code is omitted, but it would technically just simply upload it to attacker's command and control server. Okay, so a short snippet of code, and now I'm going to compile it. So when I hit a build button, and then I will navigate into applications build directory. Here I'll find main activity dex file, and when I'll click on show bytecode on main activity, I will get a smiley code. Again, don't worry about smiley code. It's a little bit less readable code, but still completely valid. So I'll copy paste this code. So here this line says that it will basically do, as I had a call for steal function, so this will call steal function in this main activity class. So here is the code of steal function. I don't have to do nothing special. As I said, I will take these lines for invocation of steal function and code for steal function itself and drag and drop it into the original application which I decompiled. So now the original application is containing this payload which will exfiltrate this JWT token to attacker's server. And now I will just use compiler it back with APK tool, assign it, so simple steps. So this is a whole chain I'm talking about. This is an attack I'm trying to warn you about. So someone may repackage application, spread it amongst your users, then collect or harvest all the JWT tokens, and then use it to impersonate those accounts. So it's really simple and I think really understandable kind of attack. Like in this case, even any like JWT expirations and similar things won't help you, because obviously if the JWT will expire in like a minute, 5 minutes, attacker doesn't care. He already can access this JWT quickly enough. So I will show you the next part. This is how will attacker probably act. So attacker will get the JWT. Attacker will, in case of Firebase, also need a Firebase key. Luckily, this Firebase key can be simply extracted from your application. I'll need not a simple strings and grep for that. So your application and these are some starting characters of every Firebase key, so I'll give your API token instantly for Firebase. And I'll use these two parts to impersonate the application which I've shown at the start of this talk. So I'll first start with checking that the token actually works. So here is some Google API which can validate the JWT. So I'll just post the token, and I'll see that initially when I had some wrong token here, it was a bad request. But the moment when I changed it for a valid one, which I extracted this way, I was 200 OK. In this case, I've used a JSON structure for this transaction. So as an attacker, I would need to extract also the format of the transaction, which would be simply possible from the code or somewhere else, maybe do some man-in-the-middle attack and check the structure itself. So I'll omit that part because I already know it's doable. And I know that I need this structure which says amount which will be transferred and recipient or like beneficiary of this JSON. So attacker would probably change recipient to his ID or whatever. So in this case, I'll try this existing JSON and with the provided authorization token here, and we can see that when I send a request, I'll be 200 OK, status success. So this is the first part, and this is what would attackers probably do in mass. Okay, so now you've get the taste of what this attack about, and I will show you the second part, and that's how to protect from it. And I will show you those technologies I talked about, so RASP, app attestation, okay? Okay, RASP shielding. So what is RASP? Because you've already maybe seen other talks on this topic. I will say it in my own words. So I always envisioned this RASP as some policeman who is sitting in your application and looking for threats, and whenever they emerge, this policeman will try to do something about it. Okay, that was a little bit creative. So yes, it's traditional thing which will check if the device is rooted, if your application's integrity is intact, if there are no others that your intellectual property won't get stolen, to ensure some DRM and things like that. So you can, for example, use it to control that your application is installed only from approved stores. For this, I can highly recommend OWASP Mobile Application Standard, which is a really evolving standard for mobile application security. And it's really good because on the left side, the mobile application security verification standard is like a philosophy how to approach overlay the security for every kind of application. So what are needs for banking applications, what are needs for health sector. So this is more a philosophical part of standard. And the mobile application security testing guide, that's the middle part. That's the really great set of checks which need to be performed to like pen test application to check that there are no issues left, that there are no simply exploitable vectors in the application. And this is something that's used mostly nowadays to ensure that application complies by step to ensure that you didn't miss anything. And the thing on the right side, this checklist itself is the checklist itself. It contains like 90 checks. I have a picture somewhere. Yes, it's here. So yes, it's unreadable, but this big file is in fact those 90 checks which you need to go one over each other to ensure that you didn't miss anything. They are separated into like various categories like architecture, networking, cryptography, storage, and resiliency. And the Rust part I'll be talking about fits in this resiliency category. The resiliency category is the highlighted bottom orange square, and it's mostly used for financial application, health application, tech application, in general applications which like deal with highly sensitive assets and which can do highly sensitive operations. And speaking of popularity of Rasp, like the answer, how many apps actually uses Rasps? That is hard to find. For root detection only, but it's quite popular. And you can see that it's mostly in finance applications, business and medical applications. These are the top sectors where it's like expectable to come to close to sensitive operations. And here are some examples of popular apps like Canva, Burger King, Samsung Gift Indonesia. So this is some like overview where you can find Rasp. Here are some hard data. 26% of applications lack data protection. 40% lack or have vulnerable encryption, and 64% of financial applications lack code protection. So this protection overlay is not yet ideally established in all applications. I will quickly explain what's root detection. So root detection is something people traditionally like to fight against, there's ongoing discussion if you should be able to run on rooted device or if you should somehow warn user or what to do actually. So for root detection, we usually check some signs of rooted device. So it's usually some binaries like magisk, supersu, sudo, and other attributes of rooting. But more important is like what to do if you have a rooted device. One really great approach I've seen with one of our customers is that they'll display a warning message to a user with some special code, and then the customer can call support, and support will help customer to decide what to do next or how to behave in such scenario, which is really, I think, a fair solution. So you don't have to, for example, kill such application to prevent user being endangered. Speaking of debugging detection, this is a field where you want to prevent someone, probably some reverse engineering, trying to get into your application. There are some attributes like debug, if is debugger connected, or flags in application info or build config, which you can yourself check that if these flag debuggable or debug are present, your application can be debugged. So it makes work of reverse engineer much easier. Then there are popular tools for hooking. Hooking is another thing that can be detected by Rasps, and hooking are like dynamical instrumentation things which again allow attackers to, or reverse engineers to navigate in your application, modify its flow, maybe extract its secrets, or to better understand what your application is doing and to quicker the pen testing process. One of the interesting checks we provide in our RASP is application binding, because in past it was possible to transfer a whole application which was already installed and set up, enrolled, whatever, on customer's device, take a whole application and transfer it on some another device where it could be pen tested. So this vector can also be checked, and it's done by storing the key in key store. And if we find this key store, this key in this key store, we can know if it was or it wasn't transferred. Really popular area is emulator detection, and you can imagine, for example, game cheaters who like to use of those third-party emulators to get some advantage in their gameplay, to be faster in, for example, shooting or whatever. There was a really great talk on this topic yesterday. So this detection of emulators is again really popular and required. So for example, we managed to do detection of Android emulator, which you all know, but we also can detect BlueStacks, Nox Player, LD Player, and other common emulators. Okay, I'll skip this. And this is one of the best things I can give you today. This free RASP library we developed like 1 year ago and published is today used more than 1,000 applications, and I mean 1,000 of like applications, not users or devices, like really big number of devices is running this library today. And this library is for free, so you can try it on every mobile platform. So we support Android, iOS, Flutter, React Native, Cordova, maybe others. And this is the RASP we decided to give away for free. This is something that makes us unique in this, because we saw that a lot of people need to protect their applications, yet this RASP protection was like really costly or maybe hard to integrate. So we developed this free library which will give you a lot of detections, a lot of checks. I will show you. So you can check it on GitHub. It's named FreeRasp, or on PubDev under the same name. Here are thread directions. This code actually comes from a Flutter flavor, but I think that's perfectly readable. So FreeRasp allows you to check the routing, or as we call it, privileged access, debugging, simulator, applications integrity, like its checksum and other things. Whether it comes from unofficial store, because in FreeRasp configuration you can set up which stores you actually allow or disallow. You can check if hooks were found, like Frida or Medusa or exposed. Also device binding, that's the binding application to device. I think there is also, yes, passcode, so it allows you to check if device has or has not allowed lock screen basically, or other technology used to lock the device. So you may prevent, for example, or warn user that this your application is not suitable to run on unlocked device. We also provide access to like to check if secure hardware is available. I don't know how many of you already worked with secure hardware or secure storages, but that's like a separate hardware thingy which is on or may not be present on device and is used for more secure way how to store secrets, tokens, and things like that. And we have some special for iOS like device ID or obfuscation issues. So we can, for Android, we can check if your application has enabled obfuscation. In that we mean mostly ProGuard if it's properly configured. So you can use it to check that your application is secured in most areas. FreeRasp also gives you a regular report, so your whole device fleet can be summarized in this nice PDF, which will be dropped to your email, so you can check if your device fleet or if there are any unexpected breaches or what's some average incident rate on your fleet. So this is another great thing we provide. And this is one of the differentiators between our free service and our business services, because we use FreeRASP to collect signals, but not any other data. And what's really interesting part, which I was actually surprised, is that we provide FreeRASP as is, as a freemium model, but we don't provide sources. It's closed source, so you should technically be afraid. Yes, I warned you not to use closed source things or to check sources. Yeah, right? So there actually emerged a really friendly community of pen testers, and people are actually pen testing this FreeRASP, so you can check yourself or check some other report to see that no one else was able to find any vulnerability or nasty things. So this is actually a funny thing when we provide closed source thing, but yet we think that it can be trusted because you can find security reports on the thing, which is, I think, quite exciting. Okay, so this RASP thing is usually nowadays considered to be like a cat and mouse game, because the RASPs can be bypassed, can be sometimes mitigated. There are some anti-RASP scripts, there are some FreeDAS scripts which will allow to bypass most known vendors. And to prevent that, we still recommend to go server-side first. So you should still keep anything what's possible on your backend side. And for that, as I already said, that RASP can be cut off, we developed a special technology which will allow you to detect, for example, on your API side, that your application calls to your backend side, because your backend is the most valuable part of your business, that all the coming requests are coming from your application. So this will basically help you to prevent API abuse, to prevent botnets, fake registration, some man-in-the-middle attacks, brute force attacks, and other nasty things which you have to somehow solve on the API side and not on your client side. So for that, we have something we call device and app integrity proof for backends, or under brand Epicrypt. I'll skip here. We developed something which you can imagine like a super-powered token. Because whenever you use some third-party service, some paid service, or something like that, you are required to add some token to your API calls. So you have usually some tokens which you need to access services. So you can imagine Epicrypt to be like super-powered token, which is generated in your application's code on your application side. And this token, we call it cryptogram, contains all the various threat signals we are able to collect on the application side. They are encrypted, and you will just send this token to your API. And on your API side, you can filter out requests without this token, obviously. And whenever you will see that this token has, or the threat signals in this token are like you will see that though there is some privileged access, some hooking, or other threats we defined, you can also decide what to do with such requests. So this big string contains actually JSON with all the threat signals we collected, and it's up to you to decide what to do next. But you will be sure that you are accepting only genuine and legit calls, only from healthy applications, only from your applications. So I will skip this. So I will show you how to use that, how we use it. So here again is the application and my postman. And here's the transaction, which was formerly successful. So I will move on to another endpoint, which is protected by Epicrypt. So basically, the request, before it gets processed by the backend, it will come through some middleware. And this middleware will access the Epicrypt token. So in this case, if attacker will do a call against not Epicrypt protected backend, or if attacker will omit this Epicrypt header, the backend will forbid. Okay. So when you will include the Epicrypt header, your backend will know that it's safe, and you will know that your backend was protected. Okay, I'll have to speed up, but I hope that you get the idea. So I wanted to really thank you for being at this talk, and I hope that at least you learned something new regarding mobile security or overall aspects, what to protect and how to protect. So thank you for being there. Enjoy the rest of this conference, and definitely come to say hi to our booth in the corner, DALSEC booth, or you can contact me. So thank you and enjoy the rest of the day.